so I'm going to go through now one of the stats questions, which is one that caused us a bit of trouble. The first part of the question will just ask us to draw a Venn diagram, bearing in mind the fact that A and B are mutually exclusive and A and C are independent. Now, this condition doesn't affect what our Venn diagram looks like, but this one does. Because A and B are mutually exclusive, they can't overlap, okay? So if this was a situation, I would tend to draw my sample space S having A, B and C. This way, sorry, A, C and B. This way, A and B clearly don't have an overlap, okay? You could have also drawn these two separately because we didn't know any information about the relationship with C and B. So you could have also drawn those separately because we didn't know if they're mutually exclusive either, okay? Because these are independent, it also implies that there's likely to be an intersection. So this is my sample space S, okay? Now I'm required to use the information given in this part of the question, okay, to relate it to this. So we were told what the probability of A was, we were told what the probability of B was, and we were told the probability of A or C, okay? And here, in the first part, we were asked to find the probability of A given C, okay? So we put that in our conditional probability formula. The probability of A given C is the probability of A and C all over the probability of C. Now, because A and C are independent, I'm now able to say that A and C is the same probability of A times by the probability of C. And I can clearly see that these are going to cancel out, and I'm just left with the probability of A, which is 0.2. Okay? So that was part B. Part C asked me to find the probability of A or B. Okay? So I can apply this into the formula that I know and see where I'm at. Okay? So I've got most of the information here. I've got the probability of A, which is 0.2. I've got the probability of B, which is 0.4. Now I'm asked for this bit here, the probability of A and B. Okay? Now, because A and B are mutually exclusive, there is no intersection. This is just nothing. So the probability of A or B is simply 0.6. Okay. Now I've got part D. This was the hardest part. I'm asked to find the probability of C. Okay. I don't have that. The only thing I've actually got in terms of C is this here. So I'm going to perhaps guess that it's going to require me to use that part, which I do know to be 0.7, and then think about what formula I can derive from the probability of A or B, or C, sorry. So I do know this information about the probability of A or C. Okay, so I do know that. I do know the probability of A, 0.2. I don't know the probability of C, so I'm going to leave it as an unknown. But I do know, thinking back to the first part of the question, that because these are independent, the probability of A and C is the probability of A times by the probability of C, which is the probability of A times by the probability of C. I can now see that I've got an equation here with just one unknown. So if I start to manipulate this, taking away the 0.2 from both sides, factorising out the probability of C, I can start to formulate an equation. So this will become 0.5, 0.8, so I can divide by that. And I can see now that, simplifying that fraction, probability of C is 5/8. So in summary, the best way to answer questions like this is to look at what information you're given. Think about formulae that you can generate from these terms, and then eventually you'll start to see how things fall together. But just remember that when they're independent, the probability of one and the other is the fact that you can multiply. And when they're mutually exclusive, there is no intersection. So that was the key bits of information that you needed to be able to answer this question. Okay?